Maybe wait a minute for people to come. Okay, I think everyone should be here. Okay, let's get started. So today I'll talk about continuity and then derivatives. Yeah, so we'll do some questions on continuity. So if the question asks like, remember continuity at A means limit x goes to A, f of x is f of A, right? So it means the limit is the value you plug in. So in particular, it means like limit exists and it's equal to what your function is defined at A. So example, right? Find numbers where f is discontinuous, right? And if they give you like f of x is x squared, I'm making this up, but actually I think I took this one. I didn't. I took it from the book. So -1 less than or equal to x less than or equal to 1. Oh, sorry, less than 1. And then 1 over x if x bigger than or equal to 1. So the first thing you should ask is, right, obviously we have to check boundary terms, right? If you remember, like I'm sort of defining like, let's assume like this is my bounds. I have a function here, a function here, and a function here, right? So it's possible like you jump at boundaries, right? So you ask two questions. First, is it continuous? So in this case, our boundaries are -1 and 1, right? So is it continuous outside boundary terms? Outside boundary terms. And then two, check boundary terms. So my first question, right, is, so for 1, is x squared continuous on -infinity to -1? Yes or no? Yeah, it's actually continuous everywhere, right? So yes. So now is x continuous on, so aside from the boundary, right? Is x continuous on -1 to 1? Yeah, it's still a polynomial, right? Now, is 1 over x continuous on, outside the boundary is 1 to infinity, right? So is there any issue with, yeah. So no, it's not continuous at 0, but we don't care, right? It's defined, it's only defined from 1, when x is bigger than or equal to 1. So even though 0 is a problem, it's not an issue in this case. Okay, so there's no issues here. So the only chance we're going to have discontinuity is at possibly -1 and 1, right? Now note if I swapped it, right? If the 1 over x was in the middle, so if it was x squared 1 over x and x, right? If it was that order, then we would have a discontinuity at 0, right? If like 1 over x was in the middle. So that's why we always do 1 first, and then we check the boundary terms. So, but in this case, 1 doesn't, 1 is fine. So I'm just gonna erase this. Keep everything on the same page. So from here, right, you check the limit at 1, that -1 first exists, right? And then you're done. So at -1, right, what is limit x goes to -1 from the left? Well, this is, I'm taking values smaller than -1. So I'm using x squared, and if I plug in -1, I get 1. And if I take limit x goes to -1 from the right, I get that this is x. So this is -1. So these are not equal, right? So for 2 discontinuous at -1, and then you do the same thing for 1, right? So same exact thing. I'm keeping on the same page, so just to keep the definition here. So again, limit x goes to 1 from the left. F of x is limit x goes to 1 from the left of x, and that's 1. And limit x goes to 1 from the right f of x is limit x goes to 1 from the right, 1 over x, and that's 1, right? So it's continuous at 1. So the only discontinuity is at -1. Okay, so that was just like warm up. So is everyone, hopefully, does everyone, remember what continuity is now? Right. So, okay, let's do something, a bit different. So for what, this is still continuity, for what value c is the function f continuous on -infinity to infinity? And they give f of x is cx squared plus 2x. This looks messy. Plus 2x if x less than 2, and x cubed minus cx if x bigger than or equal to 2. So again, you do the same thing, right? You apply 1 and 2. So let me ask, no, if I pick any value c, will it be will any value of c make cx squared plus 2x continuous, outside the boundary, right? Continuous from -infinity to 2. Is this true? Like if I plug in any value of c, is that function going to be continuous on -infinity to 2? Yeah, right? I mean, it's a polynomial. So, and then similarly, will any value of c make x cubed minus cx continuous on 2 to infinity. So this is yes. So if I plug in any value of c, is x cubed minus cx going to be continuous on 2 to infinity? The reasoning should be the same as 1. I mean, it's a polynomial, right? So you see, the only problem is boundary term, right? So here, the only possible issue is the boundary term. So c, you know, so what do I need, right? I need limit from left to be limit from right, right? To be equal to limit from right. Kind of like how, you know, these problems were, right? I needed the limit from the left and limit from the right to be equal. Well, let's what is limit as x goes to 2 from the left? Well, this is limit x goes to 2 from the left of cx squared plus 2x. And if you just plug it in, 4c plus 4. And x goes to 2 from the right is limit x goes to 2 from the right of x cubed minus cx. And what is that? That's 8 minus 2c, right? So these should be equal. And then you're done. So 8 minus 2c. Let me see. I was trying to do it in my head, but 6c equals 4, right? So please tell me if I made an algebra mistake. I always make algebra mistakes. So c is 2/3. Yeah. Everyone clear on this? Yes? No? It's honestly the same thing as last problem. Or like same concept. So okay. With that being said, let's do one more. So find values a and b that make f continuous everywhere. So x squared minus 4, x minus 2, if x less than 2, ax squared minus bx plus 3. I mean, I don't know why the book wrote it like this, right? I plus 3 if x 2 less than or equal to x less than 3, and 2x minus a plus b if x bigger than or equal to 3. So again, let me really quick, right? On negative infinity to 2, right, outside the boundary term, is x squared minus 4 over x minus 2 continuous? Yeah. Do we have any? Because if it's not, we're done. Like no value a and b will work, right? Because if you're not continuous, like from negative infinity to 2, you're not going to be continuous, like on all of our. It should be, right? So here the only issue is at 2, right? So the only issue is at our boundary term. So outside the boundary, like this you know, this rational functions, there's no issue, right? And clearly, like no matter what a and b are, right, it's going to be a polynomial. It's going to be continuous everywhere. So we only need to check at jumps, right? So to make it continuous at 2, to make continuous at 2, right, you need limit x goes to 2 from the left of f of x to be equal to the right, right? But let's see what the limit from the left is. So this is, I'm just gonna, divide out, right? This is x plus 2, x squared minus 4 divided by x minus 2 is x plus 2. So I just going to skip the step, but this is 4. And limit x goes to 2 from the right f of x is limit x goes to 2 from the right ax squared minus bx plus 3. Again, your first rule I told you, plug in. So this is 4a minus 2b plus 3, right? Yeah. So these should be equal. So I get 4a minus 2b equals 1, right? So to be continuous at 2, I need this to hold. Now to be continuous at 3, right, the other boundary term, I need limit x goes to 3 from the left, right, which is limit x goes to 3 from the left, ax squared minus bx plus 3. What is that? 9a minus 3b plus 3. And then limit x goes to 3 from the right. I need these to be equal, right? So 2x minus a plus b. So 6, right? So 6 minus a plus b. So I need 9a, sorry, I'm running out of room, but 9a minus 3b plus 3 to be equal to 6 minus a plus b. I'm going to move all those, so I get 10a minus 4b is equal to 3, right? Okay, can I move on? Can I just say, you have two equations, right? You have 10a minus 4b equals 3. I mean, it's just algebra from now on. Can I move on? Like, you have two equations, two variables, solve for it. Is everyone good? Or do you need me to do this for you? I feel this is just algebra at this point. Whoa, no. Sorry. Okay, so I completely unshared, but okay, yeah. Is everyone good with that? You're just solving a system of equations. Like, I don't. Okay. So let's go over tangent lines and derivatives now. So this, remember, right? What is the tangent line, right? So it's the line. So if this is the point, right, the tangent line at the point. So if this is the function f and this is the point a, right? So this is a f of a. Picture wise, it's like the line that touches your, your curve only once at that point, right? And it sort of has the same slope as the, the same slope as the slope of your function. So tangent line to f of x at x equals a is the line that passes through, right? So it says it's at x equals a, right? So so it should pass through the point, a f of a. So a f of a and has slope of f at a. Now, of course, I never define what slope at f is. I mean, if I gave you a line, the slope is m, right? Y equals mx plus b, but we never really define what slope of a, slope of a curvy thing is. So let me just say, remember, we approximated slope, right? Slope by taking slopes of points close by. So that was sort of what you did with what was it, like average velocity, instantaneous velocity, right? So remember, like you basically took, change in y over change in x, right? This is change in y over change in x, right? For x close to a, right? So if a was 2, you would do like 2, you would pick the point like 2.001, right? And then you would calculate change in y over change in x to get like the approximate slope. So let me just say, how would you get real slope? How would you get actual slope? It's actually not that bad, right? What does it mean to take x closer? The closer and closer you get to a, the more and more better the approximation is, right? So how do you get the exact thing? Well, you just let x go to a, right? So this is, so tangent line has slope, has this as a slope, provided limit exists. Does everyone see that? Like, right? I mean, if you think about it, like if you take points close to A, you get a better and better approximation. So how do you get the exact approximation? Well, you just let x go to A, right? take the limit. Everyone clear? Yes? No? Okay. So we have a name for this, and it's called the derivative. So derivative of f at a, right? We call it f prime of a. So the book writes it two different ways, right? It's honestly the same, right? Both in both cases, you're going to a, right? Because if you see here, like if h goes to 0, a plus h goes to a, right? So it's just another way to write it. So equivalently, f of x minus f of a over x minus a. So note they simplified the change in x, right? So so note, it should be change in y over change in x, but if you have change in y, right? What's the change in x? It's a plus h minus a, right? So these cancel. So they sort of did like an extra step, but hopefully you all noticed that. Okay. Yeah, because a lot of people might wonder, this is not changing x, and the point is they just simplified it. Of course, provided limit exists, right? So no, if the limit doesn't exist, we just say it's not the derivative doesn't exist, or it's not differentiable. Okay, with this being clear, right, we can now find actual velocity of word problems. So let me move on to the next slide. So if I gave you like word problem example, the displacement in feet of a particle. So I took this from the book. Yeah, I don't ask me about particles in physics because I don't know anything about it. So moving in a straight line is given by s. So if you like, this is s of t, right? But no, s of t is 1/2 t squared minus 6t plus 23. Yeah, okay. When t measured in seconds. So you know, the question is find velocity at t equals 8, right? So this is the actual velocity, yeah, the actual slope, right? So in this case, right, you just use the formula. So remember, the formula was basically find s prime of 8. Formula, remember, f prime at a. Yeah, by the way, we read like this thing as prime. Yeah, f prime at a is limit x goes to a, f of x minus f of a over x minus a, right? So s prime at 8, using the formula, is limit x goes to 8. In this case, our variable is t, s of t minus s of 8 over t minus 8, right? Sorry. Oh, that's my aunt. Okay. So from here, it's just plug in. So 1/2 t squared minus 6t plus 23 minus, you plug in 8, right? So I'm just gonna, you know, so 8 squared is 64 divided by 2, 32 minus 48 plus 23. Again, please tell me if I made an algebra error. T minus 8. And from here, it's just, you know how to solve limits. So use your solving limits ability. So what is this? This is 1/2 t squared minus 6t. So what is this? Subtract 23. It should be minus or plus 16, right? Because the 23s cancel, and then negative 32 plus 48. So over t minus 8. So again, if you plugged in 8, you would get, 0. So it means there's a simplification. Whoa, sorry. There should be t's. My variable is t. Okay, so limit t goes to 8, right? So let's factor out the 1/2. I never really liked fractions on the leading coefficient. So you get t squared minus 12t plus 32 over t minus 8. And then this is 1/2 t minus 8, t minus 4, t minus 8. And if you plug in, right, why do I keep writing x? Sorry. I guess if you flip the x like 45 degrees, you get a t. So t goes to 8, 1/2 t minus 4. This is what? 2. Yeah. I mean, honestly, like, if you're gonna take anything, just use the formula. Yeah, I don't think it's that bad. So I think on your homework, I think one question was find the time first, right? Where like something happens, and then it asks for velocity. So the second part is just velocity at whatever answer you found in part A. So it's like s prime of whatever answer you found in like part A. So if I remember correctly, is everyone clear on this? Yeah. So to find the actual velocity, use the derivative formula. You can use this. You can also use use the other one. You will get the same answer. A plus h. Yeah. You could also use that. So you'll get the same answer. Okay. Everyone clear so far? Yes? No? Okay. So let's talk about tangent lines. So note, let me just key point. before I ask you, like, forget tangent line, right? So let me just write the key point first. If you are given f, the value of f at a, right, for some number a, and f prime at a, you have the tangent line, right? Line to f at a. Agree? Because the tangent line to f at a, well, let me ask you a question. Like, forget the word tangent. To get any equation of a line, what do I need? Like, if I told you, like, what information do I need to get like an equation of a line? I would need a point and what else? So let me just say how to get equation of a line. Yeah, so this should be algebra. So if I gave you a point, is that enough to get an equation of a line? So if I tell you the line passes through like 0, 0, is that enough? So what else would you need? Yeah, you need another point or a slope, right? So I need 2 points, right? Because with 2 points, I could find the slope, right? Or 1 point plus slope, right? So it's easy, right? I mean, here you have the equation of tangent line because I again to get the point. Well, the tangent line to f at a, it tells you the point, right? It's a f of a, right? And remember, I said if you have the value of f at a, so you have this, right? And slope, well, the slope of the tangent line is f prime at a. And so if you have that, you have the line, right? You have a point and a slope. Once you have a point and a slope, you can get the equation of a line, right? So next, if you are given equation of tangent line, right? So a tangent line is just, a line is just a point and a slope, right? So tangent just means it's a particular point and a particular slope, right? So in this case, it has to be the point at f at a and the slope f prime. So you have vice versa, right? You have a f of a and f prime at a, right? This is easy, right? Because if I have the tangent line, I write it in the form y equals mx plus b. So m would be f prime at a. Remember, the tangent line has slope f prime at a. So if I have the equation of the line, right, and I also have f of a, right? F of a is just ma plus b, right? Okay, everyone clear on this? It's like it sounds like obvious, but but that's really all we'll be using for these next few problems. So example, find equation of tangent line. Line to graph y equals b of x at x equals 6 if b of 6 is 0 and b prime at 6 is a negative 1/2. This is easy. So we, again, it wants us to find equation of a line, right? So we are in here. So to get equation of a line, all I need to know is the value of my function at a and the derivative at a. Do I have that? I have the value of my function, right? At 6, it's 0. This is my point. And do I have the derivative? Yes, I do. My slope is -1/2. And again, once you have a point and a slope, you're done, right? You just use point slope form. But by the way, I don't know if WebAssign, I think WebAssign wants you to write it like of the form mx plus b. So like, if this wasn't 0, I'm saying you probably had, move it to the other side, right? At least that's what I would assume. Okay. If equation of tangent line to curve y equals f of x at the point a equals 2. So we have the equation of the tangent line in this case, right? Find f of 2 and f prime at 2. So again, in this case, we are here. We are in this case. We are given equation of a tangent line. And again, I'm telling you, you could find the point and the value, right? You just look here. If y equals mx plus b, m is your slope, and the value of your point, you just plug it in, right? So let's do that. So we have, this is, it's important that it's tangent line at 2, yeah? If it was at 3, I can't answer this, right? If it was at 3, I can only find f of 3 and f prime at 3. I won't know what f prime at 2 is, just knowing tangent line at like a equals 3. So this is 4x minus 5. So what's my slope? This should be easy. What is my slope? Yeah, so f prime at 2 is 4. And what is my value? Well, I just plug it in, right? So y equals 4 times 2 minus 5, that is 3. Because again, right, let me just say, they share the same point and the same slope, right? Tangent line at like x equals, in this case, 2. This is 2. This is poorly drawn, but let me draw better. It should only touch once, but they share the same point and the same slope, right? So if they share the same point, then you just plug in 2 to your equation and you'll get your point. So again, this is your answer. Everyone good so far? Yes? No? Okay. By the way, I'm not saying f has to be a parabola. By the way, just if you understand by picture, but like this is just an example. So, okay, let's do 2 more. If tangent line, just so everyone's clear, if tangent line to y equals f of x at 4, 3 passes through point 0, 2, find f of 4 and f prime at 4. It's almost the same exact question, right? So I have my tangent line at x equals 4, right? And I want to find f of 4 and f prime at 4. Except it's a bit harder in the sense that, here they gave me the equation, right? But here they don't. But we can easily find the equation, right? Because I have 2 points where the line passes through, right? I have the line, a line, if you give me 2 points, right, the line is uniquely determined, right? There's there's only one line that passes through like exactly these 2 points. So so this is an algebra question. Given 2 points, how do you find equation of line? How do you find equation of line that passes through those 2 points? This should be somewhat a bit, you know, I hope it's review, right? You could find the slope first. So 2 minus 3 over 0 minus 4, -1, -4. So the slope is 1/4, right? In this case, they give you the y-intercept. It's 0, 2. So y equals 1/4 x. Was it plus 2? Yeah. So now this is equation of tangent line, right? So you see, like, instead of, it's the same exact thing. Like the previous question gave you the equation. Here they gave you the 2 points, which in turn you can find the equation, right? So again, f prime at 4 is a fourth, right? And if I plug in 4, f of 4 is 3. Everyone good so far? Yes, no. Okay. So let's do one more thing and then we'll call it a day. So this one might be a bit hard. So find equation of tangent line. Tangent line at y equals, oh, sorry, this should be of. So of my function y equals, so it's a sort of like a parabola, right? 5x plus 1 at 3, 4. So again, for a line, I need a point, I need 2 points, or, but in this case, I don't have the second point. I need 2 points or a point and a slope, right? So here, right, I have the point already. My point is 3, 4. Well, how do I find the slope? Well, I know this is tangent line at x equals 3, right? So if you like, this is f of x. Then it should have the same slope. Then the tangent line should have slope f prime of 3, right? So slope is f prime at 3, right? Because my x value is 3. So, but right now we don't have this. Well, but we could find it, right? I mean, it's just, you do the same thing. X goes to 3. So this is f prime at 3, right? F of x minus f of 3 over x minus 3. And then same exact, it's just algebra from here on. 2x squared minus 5x plus 1 minus 3 squared is 9. 9 times 2 is 18 minus 15 plus 1 over x minus 3. So please tell me if my algebra is wrong. 3 plus 1 is 4. 1 minus 4 is -3. Let me see. So does this factor, so this is x, I'm just going to guess it's something like this. X minus 3 over, is this right? So let me see. 2x squared plus, yeah, okay. So this is 7, right? 2 times 3 plus 1. So this is 7. And then you're done. You have your point is 3, 4, and your slope is 7. So your tangent line equation is so this is what I mean by WebAssign. I think they want you to move everything, of the form y equals mx plus 3 plus b. So 7x minus 21, y equals 7x minus 17. Okay, everyone good on this? Hopefully, like, if you're confused, just a tangent line is just a line. Yeah, it's just a line with a line. You need a point and a slope. So tangent line just means your point is a specific one. It's the value of f at a, and your slope is also a specific one. It's f prime at a. So it's nothing special. It's just a line with like a certain slope and a certain point. So, okay, everyone clear? Yes. Okay. So that's all I have for today. So I think that should cover